This video is about the unit circle. We will introduce 30, 60, 90 and 45, 45, 90 special right triangles and how they are used in the unit circle. We'll also talk about how to memorize the sine, cosine, and then tangent ratios for multiples of 30 and 45 degrees. Let's get started. The unit circle is critical to memorize if you're going on to calculus and beyond. So noticing and understanding patterns within the unit circle will be very important to memorize the unit circle. And the unit circle is built from these 30, 60, 90, and 45, 45, 90 special right triangles. So let me first introduce 30, 60, 90 special right triangles. If I take an equilateral triangle and the angles in a triangle add to 180, so if I divide by 3, I get 60 and 60 and 60 for an equilateral triangle. Okay. If I cut that triangle in half this way, boop, then I'm cutting the 60-degree angle in half, and I have a right angle there. So I get here in green a 30, 60, 90 special right triangle. Okay. Now, on the unit circle, our radius is going to be 1. Okay. And that'll show up with a hypotenuse of 1. Okay. And then this shorter leg over here is from, well, let me go back. It is a equilateral triangle, so this length is also 1, and I've cut it in half, so this is 1/2. Okay. Now we don't know what this longer leg is in this 30, 60, 90 special right triangle, but we do have the Pythagorean theorem, and we know that a squared plus b squared equals c squared. And c is always the hypotenuse, so 1 is the hypotenuse. Okay, and I'll just plug in 1/2 squared plus x squared equals into a and b. Okay, and then I solve the Pythagorean theorem. And so I find that this longer leg right here is equal to the square root of 3 over 2. Okay, so filling that in down here, I have this is 60 degrees. Okay, this is 1/2, and this longer leg is root 3 over 2. Okay, similarly, I also have a 30 degrees here because the angles in a triangle add up to be 180. And this hypotenuse is also 1, which means the short leg is 1/2, and the longer leg is root 3 over 2. Okay? Now, the other special right triangle we should be aware of comes from a square. So if I take a square, and this is 90 degrees, and all sides are 90 degrees, and I cut it in half diagonally this way, okay, then I've cut the 90-degree angle in half, and I get 45 here and 45 here. And this is a 45, 45, 90 special right triangle. Again, in the unit circle, the hypotenuse will be 1. And so I got to figure out what these two sides are. But again, I have the Pythagorean theorem, a squared plus b squared is c squared. And the hypotenuse is always c, and so I get 1 squared there. I get x for a and x for b. And I solve this Pythagorean theorem as well. Now, let me point out, I've got to the point where I have 1 over root 2, but I want to rationalize my denominator, and so I'll multiply top and bottom by root 2, and I get root 2 over the square root of 4, which is 2. So basically, both of these legs are root 2 over 2 and root 2 over 2. Okay, so I get root 2 over 2, and I get root 2 over 2. So before I actually move to the unit circle, let me tell you that these numbers, 1/2 and root 2 over 2 and root 3 over 2 are really important numbers. Okay, notice that all of them are divided by 2. And even going one step further, root 1 is also 1. So basically it's root 1 over 2, root 2 over 2, and root 3 over 2. Okay, so those are the only numbers you have to pick from other than 1 and 0, and we'll get into that a little bit later. Okay, but those are some numbers to be aware of because those are the numbers that keep showing up over and over and over again. So with that in mind, let's jump into the unit circle. Okay, this is the unit circle and it looks really overwhelming, but hopefully it makes sense as we go. I'm going to start off with 0 degrees in standard position, okay? And then I'm going to count by 30 degrees as I go around. So this is 30 degrees, and this is 60 degrees, and I go all the way around. And there we go. We also have, we can also write this in terms of radians. Okay, we know that this is 0 radians. We have talked about in a previous video that this is pi radians, that 180 is pi. Okay, and now notice that 30 is 1/6 of 180. Okay, so 30 degrees is pi sixths. Okay, and that's important because I can count my way 30 degrees around this entire circle by counting pi sixths. Okay, 60 degrees is 2 pi sixths, but 2 sixths is 1/3, or this is pi thirds. Okay, if I keep going around, let's just kind of make this super clear for you. I get 2 sixths pi, and I get 3, let me move over here, 3 sixths pi, but 3 sixths is pi halves. Okay, and then I get 4 sixths pi, but 4 sixths is 2/3 pi. And then I get 5 sixths pi, which actually can't be simplified. That will stay. This is 6 sixths pi, which is just pi. I get 7 sixths pi, which can't be simplified. And I get 8 sixths pi, but 8 sixths simplifies to be 4/3 pi. And then I get, let's see here, 8 sixths, 9 sixths pi, but that simplifies to be 3 halves pi. And then I get, let's see here, 10 sixths pi, but 2 goes into both 10 and 6, and so I get 5/3 pi. And then I get 11 sixths pi, which can't be simplified. And then I'm back to 12 sixths pi, which is 2 pi. Okay, just to keep this as simple as possible, we go ahead and erase these other ones, so I only have left the simplified versions. Okay, let's go back through and look at the other ones, these 45 degrees. And if I count by 45 degrees, 90, 135, 180, 225, 270, 315, and then 360. Okay, so count by 45s. I can also notice that pi, that 45 is 1/4 of pi. So this is pi fourths. And I can count by pi fourths. This one is 2/4 pi, which simplifies, we already have that as 1/2. I have 3/4 pi, which can't be simplified. Bing. I have 4/4 pi, which is pi. I have 5/4 pi, which can't be simplified. I have 6/4 pi, which is already 2/3. Sorry, 3 halves pi. And I have 7/4 pi, which can't be simplified. Okay, so I can go ahead and erase these to kind of stepping stones to get to those. Okay, you're basically counting 30 and 45 all the way around, or pi sixth and pi fourth all the way around. So I've done the degrees and I've done the radians. The next thing is we have to understand that that the unit circle has a radius of 1. Okay, and if I forget about the circle for a second and look at this point to plot this point on the coordinate plane, I'm just going over 1. That point is the point 1, 0. Or if I go up 1, it's 0, 1. Or if I go over here, I'm going to negative 1, 0. Or if I go down to the bottom, I'm at 0, negative 1. Okay, that's pretty easy, just plotting those points without even having a tricky circle. Okay, so now I bring in those 30, 60, 90 triangles that we talked about earlier. Okay, the only options I have are 1/2 and root 3 over 2. Okay, so for this one, let me actually change colors and have it be blue. So for this one right here, the x-coordinate is root 3 over 2, and the y-coordinate is 1/2. Okay, keep it simple. As I go to this one right here, the x-coordinate is the short leg 1/2 in the x-coordinate, and then I go up the y-coordinate of a longer leg of root 3 over 2. Okay, I only have 1/2 and root 3 over 2 are my only options to use. Okay, going over to 120 right here, I'm going to go in the negative x direction, the short leg of negative 1/2 in the x direction to negative 1/2, and then I'm going to go up the longer leg, sorry, 1/2, negative 1/2, the longer leg of a positive root 3 over 2. And then I'm over here. Okay, in the x direction, I'm going negative the long leg, so negative root 3 over 2. And then I'm going up the y, the short leg for the y, and it's positive 1/2. Okay, I'm down here at, this is a 30, 60, 90, but down this direction. The x-coordinate is the long leg, but it's going in the negative x direction, so it's negative root 3 over 2, and then I'm going down in the negative y direction, the short leg, negative 1/2. And then, let's go to this one. This is a 30, 60, 90. I'm going to go negative the short leg, which is negative 1/2 in the x direction, and then negative the long leg in the y direction, root 3 over 2. Then I'm over here, just walking my way around the circle. I'm going in the positive x direction, the short leg, 1/2, and then I'm going down in the negative y direction, the long leg, and get negative root 3 over 2. And then I have this one, so I'm going in the positive x direction, the long leg, root 3 over 2, and then going down in the negative y direction, the short leg, negative 1/2. Okay. If it helps you to kind of double check your work, keep in mind that the signs in the quadrant, in the first quadrant, it's positive, positive. In the second quadrant, it's negative, positive. In the third quadrant, it's negative, negative. In the fourth quadrant, it is positive, negative. So that helps you kind of check that work to make sure that you're getting those signs correct. Okay. All right. That's the 30, 60, 90 special right triangles. And now let's look at, I think purple is fine. Let's pick a new color. Let's pick orange. Let's look at the 45, 45, 90 right triangles. Okay, that's the only number I have to work with is root 2 over 2. And so looking in this first quadrant, it's going to go positive, positive. So it's root 2 over 2 and root 2 over 2. And going in this direction, I'm going in the negative x direction, negative root 2 over 2, and in the positive y direction, root 2 over 2. And down here in the fourth quadrant, I'm going negative in the x direction, negative root 2 over 2, and then negative in the y direction, negative root 2 over 2. And then in the fourth quadrant, I'm going in the positive x direction, root 2 over 2, and then in the negative y direction, negative root 2 over 2. And that is the full unit circle, okay? And the way I honestly think about it is if it's a 45 multiple, then I think about root 2 over 2, what quadrant am I in? And if it's a multiple of 30 degrees or 30 or 60, I think about long leg, short leg, and what quadrant it's in. Now I want to talk about why this unit circle is so important, okay, and why it's important to memorize. It's because this is the perfect tool to memorize the sine and the cosine of all of these angles, okay, and then I will show you can find the tangent as well. If I pick any one of these angles, so for example, if I just pick this one, okay, this triangle as an example, okay, we're focused on this point right here. I know that I went to the left, -1/2, and up the long leg √3/2. And I'm focused on this angle right here, which is 60 degrees, but really comes down to be this angle right here is 120. So I'm thinking about 120 degrees or 2/3 pi. So if I want to find the sine and the cosine of this triangle, I use my mnemonic SOHCAHTOA, and the hypotenuse is 1. Keep that in mind. What is the sine of 120 degrees? Well, it's the opposite, this is the opposite, over the hypotenuse, and it's √3/2, √3/2 over 1, but dividing by 1 is just that same thing. So this number right here happens to be the sine of 120 degrees. Okay? And what's the cosine of 120 degrees? Well, that's the adjacent. Adjacent's right here. Adjacent over hypotenuse, or -1/2 over 1, but dividing by 1 is the same thing. And this is the cosine, which means the coordinates here are actually cosine, sine. So if you asked me, what is, the cosine of pi/4, I would think, oh, pi/4, that's 45 degrees. It's a 45-45 right triangle in the first quadrant. The cosine is the x-coordinate. It's √2/2. Now, I know that was a lot of steps, but the more you do this, you can get the hang of, okay, I can find the sine of 210 degrees because I know what the y-coordinate is right there. And you can think about long leg, short leg, and just picture the triangle and just read it off. It's actually, you get the hang of it pretty quickly. Okay, you can find the cosine and the sine for any of these angles on the unit circle. Also notice that it's in alphabetical order, cosine and then sine in alphabetical order. Now, if you needed to know the tangent of an angle, that's not sitting here directly in the unit circle, but we can divide the opposite over the adjacent, which happens to be the sine over the cosine. So if you asked me to find the tangent of my 120 degrees right here, then I would think through, okay, the sine is √3/2, the cosine is -1/2. I don't have space, so I'm going to do it down here. Actually, over here is fine. So I get √3/2 divided by -1/2. The 1/2s cancel conveniently. Boom, boom. I have √3 over -1. I get -√3. Okay, so if I have to find the tangent, I would just divide sine over cosine and find it that way. So this is the unit circle. I know that it's a lot, it's overwhelming, but there's patterns within this circle that you will get the hang of: long leg, short leg, or it's a 45-45. They're both √2/2. What quadrant it's in, cosine, sine. A lot of patterns that you can just understand and make the memorization and using this circle much more powerful. All right, this video was about the unit circle using 30, 60, 90, and 45, 45, 90 special right triangles to memorize the sine, cosine, and tangent ratios for multiples of 30 degrees and 45 degrees, pi/6 and pi/4 radians in the unit circle. Thank you for watching.